Okay, so today we're going to be going over let's see, let me know if I have sound, guys. I should. So today we're going to be going over a 820-2879 that had liquid damage that turns on but powers off randomly. So, let me get this board here or find the board. We also have a couple other ones to work on if we get time. So, think, what would cause this? This board was worked on. It's had the ISL changed. I'm just finding the right board. So, had the ISL changed and it still does not work properly. So let's go ahead and get it's low and muffled. Okay, hang on one sec. Let's see here. Okay, that should be better. Hopefully be better. So, had the ISL changed. It was cleaned, of course. So, we don't have to start thinking yet. Let's just look over the board and see if we could find anything obvious. So, let's get our microscope out, set this up, and see if we could just see anything out of the ordinary on this board and see maybe what could be remotely causing our not or shutting off randomly issue. So let's get our second camera plugged in here. Okay, so let's see. Why is a MOSFET cheaper than a relay even when they're switching at the same voltage and amp? Well, most relays are mechanical. There are solid state relays. I don't exactly know the exact answer behind that, so let's have a look. So the liquid hit the LVDS there. It hit all right here. Let's see. A couple burned pins. You can't really see this. We have someone that we're scraping there. Okay, so someone scraped those pads. They're okay. And just continue on. It looks a little nasty. It had liquid around here. So just keep continuing. Look at those resistors right there. Right there. That looks a little corroded and damaged, but I don't think that's our issue just yet. Little corrosion here, nothing major. Remember, this was clean. So we have a thick coating of corrosion near the BIOS area. Just a little corrosion here and there. The liquid hit there for sure. Continuing on. This area looks burned, like there was rework here. And being reworked there, the CPU's on the other side, so someone may have taken a heat gun. Our ISL area has liquid damage and has rework. So it doesn't look too bad, but I'm not going to trust someone else's work, and I will be changing the ISL. So let's flip it over, and I think our issue may or may not be on this side. You guys let me know. So signs of water here. We have a probe point that looks a little nasty. So here's our current sensing circuit. Have a look at that. Our pads, or this is kind of annoying, are gone for the current sensing circuit for PP bus G3 hot. So this is probably what's causing our random powering off issue. So this is going to go to the other side of the board to the ISL. As you can see, these probe points are completely gone, so this resistor is probably out of the circuit completely. So let's go ahead and run a couple wires to this. This shouldn't be that difficult at all. And this board is actually turning on, which is strange. So let's have a look and see if I can explain to the best of my ability of what these resistors do. So let's open up a schematic and a board view. This is a 2879, and that component is R7020, I think. Am I right? Yes, that is R7020. So let's open up a schematic. Yeah, MOSFETs usually are used to drive something with a smaller amperage or less draw. Oh, 2879 schematic. And search R7020. So, system power architecture to start. This is basically what it is a current sensing circuit. So you look on AC, and this is for charger sends, but could still cause issues. Let me see here. You guys probably can't see this, so I'm going to turn the monitor. You may think, why am I doing this? Let me see if I could figure out a way to focus the camera on that only. You probably aren't going to be able to see it. I probably just made it a whole lot worse than it was. Yeah, you guys aren't going to be able to see that, so no. Anyway, so continuing on, this is SMC, DC, and iSense. This may or may not be our issue, but I think we should have that there because without DC and sense, it's not going to charge, and a lot of stuff is not going to work. So that's going to tell the ISL how much current is going through, or how much current the board is pulling. So picture this. You have, let's say, I don't know, fuel pressure in a car. It needs to know how much pressure is going through to adjust the speed of the fuel pump and such like that. So this is the same thing. It needs these readings, and it needs to be able to know how much current it's pulling in order to work. So we're going to go ahead and run a couple wires to the ISL6259 chip, or better yet, the ISL, the current sensing resistors near the ISL. So R7020, this is going to go through something called charger CSI RN. So we're going to flip the board over and figure out where this is going to go on flat on the other side of the board. So we have to figure out a way to run a wire over to this side, and we're also going to check between current sensing on the ISL, but they look pretty good. They look like they were replaced, but a capacitor that looks really bad was left for some reason. So let's start. So I'm going to run a wire iron is on. I want fume extractor. And where's my jumper wire? I'm constantly losing stuff, especially when I leave or reorganize something. I move stuff and I forget where I put it. I'll just use this reel. So we're just going to run a little wire. Hopefully you guys will be able to see this. And you probably won't, but oh well. I'm gonna end up melting something. I'm trying to move my iron without. There we go. So I had my iron like caught around the microscope. That's why I used a AmScope the other day at the iFixit place. I wasn't really. I mean, the AmScope SE, whatever it is, not the SE 400, the higher end one with the camera. Um, I didn't like it too much. The working distance on it, I didn't like, and the field of view. It was. I just like my SE 400 a little bit better. Just my personal preference. So let's see. I'll move it back, so I'm just putting it in my field of view. There we go. So this board is absolutely disgusting. It's filled with hair, and so what I'm doing is just feeding a little bit of leaded solder, so it'll be easier to solder our wire when we do go through with it. Now let's get a little flux. If I can find out where I put my flux, it's right here. And tweezers. I don't like that because the way I had it soldered, it will probably break over time, so I have to readjust that. So I can see, and you guys can see. I'm going to do it this way because we're going to be running a wire flat across the board. And we don't want that to short anything or to break and then not work. I'm going to trim the wire a little bit because I don't like how MOSFETs can sustain their rated voltage and amp for long. I'm not sure. I'm constantly losing stuff. I'm putting stuff, you know, I have my tools usually on my desk and then I move them to reorganize, and I end up losing stuff as I move it. Yeah, you'd have to read the data sheets, like Aaron said, to figure out how long the MOSFET could provide its current. It's kind of like a PC power supply. It's not always going to provide peak current. I was thinking about scraping the via away. No, I better not. Better just run it on the other side of the board. Okay. Yeah, I'm not really answering. I'm just reading what people said. This is the CSIRN, and this is going to go to the other side of the board. So for your flipboard, this is going to go to R7022. So, unfortunately, we're going to have to run this wire all the way around the board. This is coated enamel wire too, so we don't have to worry about shorting anything. But trying to get it so also we don't want that on there. You know what, this is a pain. I don't want to run it. I'm going to run it around the other way. It's going to be way more practical and easier. That saves like a ton of wire off of it. So. I'm going to go on that second. I better check that resistor tree just in case that constant resistor is blown. So let me look. My leads are so dirty that they're not allowing you to read properly, so this whole board is kind of nasty. Do we have a blown resistor? 10 ohms. 10 ohms. Why aren't we reading? Makes no sense. I think they're both good. Check our other one too. I think it's good. So it's 10 ohms per resistant. When they blow higher, yeah, no, they're not blown. They're not blown. But this is, again, same thing with the leaded solder. I want to tune it a little bit. Sorry about the microscope view right now. These were actually replaced before, but you can't replace it without, you have to think why they're not turning on. You can't just replace something because you think the resistor is bad without checking why that signal is not working. As you guys saw, there's no pad. So how can that possibly work when you have no pad or no connection to the other side of the board? It can't. There's one. Good connection. Now our other one. Let's see. There's one. Our other one. Hopefully this is going to work. I don't think this is fully our issue. We have other issues that we're going to check, but this is definitely part of it. But that's not going to explain why it's shutting off randomly when on battery. So it still has to be done. But I think a lot of the shutting off on battery is just how dirty the board is. It was cleaned with a toothbrush and alcohol, but that's not going to be sufficient, you know what I mean? It may work a little bit, but it's not going to clean under the chips or anything. Where's my... Okay, so... I mean, these probe points are really bad. There's no way this resistor could have been... So our second wire. And I kind of want to change that ISL too, but, you know, someone else touched it. Now this is going to go, I'm going to double check, I don't want to make a mistake. Oh, see, I screwed up. Or did I? Yes, I did screw up. So I put that, the other one, hang on a second, I confused myself. I think I reversed the wires. I have them on the wrong way. So yes, I did. I soldered one of the wires in the wrong spot. So glad I caught that. So I driven myself crazy. So now our second wire, we go where our first wire was. And that should be good. So I'm going to clean up these joints just a little bit, so I'm going to add a little more flux. And then I think I'll replace if I feel like it. I'm pretty tired, but I'm going to. That looks good. So our two wires are run for that, and let's see. I ordered a removable fry basket handle for the ultrasonic. Yeah, that would be nice. Okay, so I think our issue with that is solved. There's a couple more things we need to address on this board. I'm just going to work, especially on these SMC, one of these SMC resistors. I need to check them. So we need to have a look at on the board. There's a couple corroded resistors near the SMC, not corroded but burned. We need to see if those are off spec because those could be causing our issue. Anytime random powering off issue, I think corrosion under something or anytime like random powering off, that's like MCP or SMC. So there could be corrosion under either. So that's a 100K resistor. We're going to see what it's measuring because it's a pull-up resistor that could definitely cause some weird stuff going on. That's 87, so it's burned. I should replace it, but I don't really think that's causing our issue. Yeah, 87.5K, that's not going to do it. Now this guy looks really bad. What's that for? So that's R6905. Looks okay, just looks really like oxidized. R69. Wait, I confused myself. What number is that? R6905. And that is a 1 tone. That's not going to be blown. Because if that was blown, it would not do anything. 1.4 ohms, not blown. Just nasty. This resistor right here for who knows what, it's covered in corrosion, looks kind of nasty. I think this is going to work just fine after the ultrasonic, and I don't think we could truly see what's going on with it without it being ultrasonic first, because we could always go back. So R1987 I want to check is R1987, 100K again. Let's see. Perfect. So I'm going to throw this to the ultrasonic. Now hang on a second, I see some problem. Probe point going to the under the SMC is really bad, and let's try and revive that probe point before going further, because that will fall apart and I don't want to run a wire under the SMC. Oh, we have a nasty via coming from, who knows, something under the SMC going to the other side of the board. We do not want to mess that up in the ultrasonic, so I'm going to try and revive it. you could save the vias by just putting a little bit of solder on them. That'll usually fix them. It won't fix them, but it's going to stop the ultrasonic from tearing them to shreds. Never just throw a board in the ultrasonic without testing, without looking at your probe points and touching them up if needed. I don't even know what you guys are talking about. Hopefully these do not, yeah, they had me up teaching. It was a fun experience though. I never anticipated that. I was just, basically, I was looking at the person that gave me 4 of these boards there. I was looking at one of their boards, and Jessica came in and brought 50, well, not 50 people, but a large group of people with her. So, and I was sitting at the scope, so I ended up teaching, or attempt to teach, component level MacBook Pro, not just diagnostics. It wasn't anything too severe, just an ISL failure as usual. Something really easy. At least it wasn't some like strange rabbit hole board like the stuff that I have here right now. But I'm trying to revive this one pad point with hopes of not having to run a wire under the SMC or anything like that, but this looks pretty bad. I don't care about running wires anywhere else, but not under the SMC. That is not fun. I'm also going to give the SMC a little light reflow before we put it in the cleaner, because I know with the condition that all this stuff around it is, I know it's going to be just kind of touching up just some areas. Like I said, with these probe points, this board is just so nasty. It just has like hair all over it. It'd be gross. So, just looking. I don't want to destroy vias in the ultrasonic. I'm trying to revive as many as I can because they may be working now, but after the cleaner they may not be. So that's what you don't want. So often savable boards become unsavable because they went through the ultrasonic. Most of these are savable. I don't think I'm gonna have an issue with any of these. So let me do a little light reflow on the SMC. I'm going to surround it with Flux. The Flux has solvents in it. They're going to help clean up all the corrosion under it. And it's also, we're going to repair any connections by doing this. Any, corroded probe points, not probe points, but any ThinkPads drain. Oh, there's two ThinkPads. There's a ThinkPad running the stream, and then there's another ThinkPad T440p that I'm running the stream on. So I'm going to switch my nozzle to the big one. We're going to give that SMC a little refill. Yeah, all laptops have their weak points. Generally, consumer grade, as usual, as expected, is going to be the less. But the drains on the T440p are just great. I mean, the thing is designed so well, and it's designed to drain the water well. I mean, it's incredible. But like Apple, I mean, any little bit of liquid on Apple is. So I'm going to start several inches away, preheating the board. If we move in too quick, we will destroy we will burn the SMC. So I'm waiting for the flux. I'll adjust this so you can kind of see it a little bit. I'm waiting for the flux to burn away except for on the SMC. And we can move in on it and we'll heat it until we see it start to move. So that flux now is burned away and then move in on it. On melt. Should be good. Now, of course, we're going to let it cool down. We're going to test it to make sure everything's screwing together. It's probably still pretty hot. We're going to get a little alcohol and Q-tips. Clean that up. We're going to just cool it down a little bit. The alcohol. Designing circuits, that is not my specialty. Someone heat gun the CPU on this. Why would you heat gun the CPU? I don't get that. That makes no sense. I'm going to look also in the microscope to see if I can see anything visually. The SMC, it looks pretty good. Definitely has some corrosion. I think it's cool enough now that go ahead, and these boards you'll want to put the heatsink back on. Well, actually no, I'm good. I'm not going to put the heatsink back on it. I'm just going to make sure that fan spins. Spinboard. Yeah, I'm not a designer either. I'm just a tech. I don't think I'd be a good circuit designer, except, you know, what a good job would be is, you know, fix engineers' mistakes. That would be a good job. No, and some of the stuff is like so obvious. Like, come on. Well, don't be stupid, you know. Design that better. I just want to make sure the fan spin. We're done. So this is going to go on the ultrasonic cleaner. I think it's going to be good. Oh, I hate these RAM slots so bad. They're a pain. So let's get got a free toolkit at the iFixit place too, and a new soldering kit for free. They at the conference they gave everyone free toolkits. So that was nice. So we're gonna do 2 to 3 minutes on one side, 2 to 3 minutes on the other. I hope we don't screw something up by destroying corroded pad points. I think it's good though. I fixed most of them. So. Yeah, I've never really done any circuit designing. Now, Aaron is a good engineer. Aaron made this MagSafe 2. Um, this MagSafe 2 with power adapter. This is pretty cool. I mean, this helps immensely. Um, just getting different voltages inside, or not voltages, uh, current pulling, so you know what the board is doing. This is useful. Then I think we'll have, what time is it, 9:45? Maybe we'll take a shot at another board. We probably won't fix it because it's an interesting rabbit hole, but I think we might go take a shot at it. board. Hot. Yeah, dropping the connectors into the bench PSU. That would, I like that idea too. I haven't killed the charger yet, so that's pretty good. Sure I will. Yeah, well, like current sensing issues, for example. If current sensing isn't working, it's going to shut the MagSafe off. On his solution, it's still going to keep running. So if you have a current sense issue or something like that, or an ISL issue, that bench power supply is still going to power it. It's just, I don't know. I'm going to try something new. I'm going to turn the board, since I did it like a minute or two, about a minute on that side. I'm going to turn it. If I could find out where I put these things, I'm going to turn it so the cavitation gets really under the chips. Kind of like turn it like this. So I want it to get really under the MCP and the SMC because those are what's having the issues right now. Kind of want to put the lid in if I get to breathe this stuff. No, whatever. Pretty cool on the ultrasonic. You could see the waves. The waves, especially when it changes frequency. Pretty neat. Thank you, Texas. The conference was really fun. I met a lot of great people there, and I even got to attempt to teach at least a little bit of MacBook board repair. Um, So it was a really fun time. Let's get our board. I get a chance to try the JBC? No, but I got a chance to try the AmScope, the expensive AmScope, and I didn't really like it that much. Okay, so we're going to turn our hot air down. We're going to clean up most of this water. So let's see. No, I didn't get the chance. I wish I got a chance to try the JBC though. Go a little higher on hot air temperature. Probably not even going to turn this on tonight, but because of the liquid. Next, we're going to move. Hi, Chris. How you doing? The next board after this, I'm going to move on to a different one. This is going to be fine, I think. Start this in the morning. I've been having a habit of. I have a Pro 13 doing the same thing. Well, Chris, shutting off randomly is going to be corrosion or something, or busted pad points or something like that. Reflow the SMC and run it through Ultrasonic. Like on this board, I'll show you. So, Chris, have a look at this. So here's our PP bus current sense, part of for PP bus current sense. So we had to run wires, right, to the ISL. Look at the probe points, they're gone. And they were like that. So, you know, these wires might break. I might want to redo those, but those should be okay. I'm just going to tack it down a little bit more. But I just ran wires to the ISL because their probe points were literally gone. So something like that. It'll randomly boot and shut off other times. Yeah, it's something like this, but booting is going to be corrosion under the CPU, like that. That's probably corrosion under the CPU. So this board is going to go into the pile, not in the pile, but into its slot. I think I got the right slot. We're going to come back and we're going to try and tackle this other board. I have this quarter fan spinning board that it's a nightmare. I can't, I don't know. I have this board that's quarter fan spinning and I can't fix it. It was working and then it wasn't. So this board, on the other hand, this is an 820 something old nonsense board. Not really, but 820-2533B. And this board does something very strange. So we ran it through the ultrasonic. It had liquid damage, not too bad though, and it's not booting. So we have no action from the CPU. We have nothing. So here's what this board does. We plug it in. The fans run on full. It does nothing. So do I really feel like putting this in the case and testing it? Yeah. So this one, what was I going to do? Get a fan. Where's the fan for this, if it even came with a fan? I'll just use this one. So this one, this board, yeah, boards like that just randomly work. So this board is pretty strange. So this board is going to, so this board turns on, you do green light in the charger, and our CPU and MCP get warm, so that means they have voltage, or they're shorted to ground. So we're gonna, but something very interesting happens. The fans run on full all the time, and it does nothing else. So let's say we have an issue with the SMC, right? Let's check our U7000 torn off. So let's see what PP bus G3 hot voltage is. This is a 2533. PP bus G3 hot. And that's going to show up. Let's flip the board over. It'll show up on a number of components. I don't think I spent too much time on this board last night. I just so it's going to show up. There's a diode near U7000. The U7000 is right there. So let's go to voltage. You might ask, why am I checking PP bus G3 hot? Well, it's a SMC issue, or SMC reason. That is 12.54 volts, so we're fine there. So, since it's not booting, let's check our chipset rails. So, yeah, try to start jumpers. I saw that, but I have nowhere near enough patience for that. So, let's open the schematic for 2533. 820 2533. Let's see. Do I have it? Right here. So let's look at check our chipset rails. So where is, there we go. So fan is spinning, it's reaching SO state. That means we pretty much have all of our rails. So let's check our chipset rails. Chipset V-core rails. PP V-core SO CPU. That's our first rail we check. So PP V-core SO CPU. I know we have voltage to the MCP because it is turning on. So PP V-core SO CPU. That is 1.15 volts. So that's good there. So next rail we check is going to be PPV Core SO MCP. So PPV Core SO MCP. And that is going to show up in this other area of the board. Or, well, let me see. So, that's 1 volt, so that's present. Now, what is that supposed to be? I'm not sure, so let's look on the schematic. Let's zoom in a little bit. We may have an issue with something that voltage 1.05 volts. That's fine. So, wait a second. Okay, so that's there. Now, I don't think it doesn't beep or anything like that, so we may even have a BIOS issue. My guess is the fans are running on fast like this. Let's reflow the SMC because it did have liquid, and there may be something caught under there. I kind of doubt it, but it's worth a shot. Yeah, the new iPhones are a joke. Do I want to reflow the SMC? No, I don't see any signs of it being corroded. You know what? Is this actually going to work? Did I do something stupid? No, I don't use the MacBook anymore. I use, I got my old ThinkPad's running the stream right now, and then I have my new ThinkPad T440p that's running, that I'm using. I'm going to plug this in. Did I screw up and did I do something stupid that it's not working? We actually have an issue here. Let's see. I've always used the ThinkPad. I was just using the MacBook for a little bit. Not going to worry about plugging anything in. I want two things. I want my speaker, and I want my speaker, and I want my LVDS cable to see if there's anything on the screen. Nothing else we need right now. So. We don't need any trackpad. We don't need hard drive. This keyboard was really sticky. Something was spilled on this. Yeah, my streams end in failure too, all the time. Oh, good green light. Let's see if it does anything. See if it chimes. Ah, it's beeping. So, you can probably hear that it is beeping. Okay, yes, it is RAM beeping. Do we have DDR3 power? Or it's a dead MCP79. So, oh, this is gonna suck. But okay, so the RAM area looks pretty clean. Let's just try something really simple. Let's try reseating this slot. I didn't notice the beeping last night. I don't think a dead MCP would cause it to beep. Could be a bad RAM slot. But a bad RAM slot isn't gonna... Yeah, is this the BGA slot? No, this is not the BGA slot. Why are we not turning on now? But it's still beeping. Let's try the bottom RAM slot just to see. I know my RAM is good. So much for a simple one. BIOS issue. You're probably spot on, QStack, because the fans run on fast all the time. It doesn't do anything. try the bottom RAM slot just to ensure. And we could also have a DDR3 power issue. Since this came in with no power, I ultrasonicked it. It did have power after that. So my guess is there was corrosion under something. I don't work on these old machines very often at all. So EFI termination resistor is right on as well. That's one thing we're going to check, but this board didn't look nasty. It just had Coca-Cola on it. It didn't necessarily look like some of them look like all nasty and corroded. But this is so old that, I mean, so now on the other slot it's beeping once. What does beeping once mean? Let's look at the beep codes on these because I have no idea, to be honest. Could this be single beep CPU? Hi, Brendan. Yeah, I've been having Lewis's luck recently. I really have. This would be the second dead CPU board here right now. So, one tone repeating every 5 seconds. No RAM is installed. No, that's not true. 3 successive tones, then a 5-second pause. Repeating. RAM does not pass a data integrity check. Okay, so this could be the CPU, or it could be, like I said, no, if I tried to reball CPU, I'd probably cause a fire or something. Okay, so one beep, so it doesn't see any RAM detected in the second slot. Maybe my RAM is bad. Maybe this RAM slot just happened to go bad, you know? I hate these bottom slots, so let's try a different RAM slot. Or a different RAM stick. Yeah, there's no hope yet. It could still be DDR power, but this board is pretty clean. You know, it's not like one of the boards that looks all nasty and burned. There was sticky stuff all over it, just Coca-Cola or something. So, it chimes. It was the RAM. No way. Look at this. Look at this nonsense. Let's see. Come on, give me. Yeah, question mark. Why is Joshua's message being held for review? Okay, so that means that I don't know what that means. That means that nothing was wrong with this. I got sent here for nothing. So, Chris, what does that mean? The sheep, what does that mean? Rossmann Group troll? I don't understand what that means, so. I can't believe this was the RAM. I can't believe this was the RAM. What's wrong with this? Who knows what's wrong with this? Because this was working. Yeah, this is a SK hijinks. So, yeah, you guessed it. So, well, let's move on to the next one. Hang on, the dog wants to go out of the room. Come on. Okay, so Chris, Q's Tech, everyone, I need your help with this one. It stumped me, and I need you guys' help. Simple as that. So, um, I have a. Where did I put that? It's here. I have an 820-3115. Had liquid damage and a lot of stuff. I replaced it. They had liquid damage on the CPU FETs. Had just liquid damage all over. I replaced the CPU FETs. It was all working. I go to put it in the case, and it quarter fan spins. And it's still quarter fan spinning. It was working perfectly fine. I replaced a couple things that were messed up. And it's still quarter fan spinning. There's no V-core. I asked Duke. He said possible use 7400. But I'm not sure. I'd really like to get this board solved. So I'm looking for suggestions. So SMC, it could be the SMC, or it could be something more simple than that we're going to try, because I did try something with tried a different resistor. No, I didn't replace the CPU buck controller yet. The FETs were actually, I think the FETs were good, because it wasn't blowing the cap and it was working. But I replaced a 402 resistor with a 201 because I didn't have it, and maybe that failed because that's similar, but it's power cycling. The CPU gets warm for a second on that, so all the rails are pulsing, all sys is pulsing as well, so it's reaching an SO state, so something is screwing it up. There was corrosion near the SMC. Now we get no grit. There we go. So it just sits here and it power cycles. Maybe there's a blown resistor. Let me see. Near the SMC, I really, this board is making me kind of mad, and I want to get it fixed because it was working, and it stopped working on me. So this resistor I replaced, there's 0.7 volts, flux and pull it. I've been doing that, and I've been tending to screw stuff, BJ stuff up recently. So that's kind of unstable on the other side of that resistor. No, it's good. There wasn't really corrosion immediately near. I wonder. I ran a wire for the system and the LEDs, and it's not really that important right now. Yeah, it's still power cycling. So maybe this wire is shorting somewhere, so I'm going to just... I could, but there's no corrosion under it, and I've already reflowed it. So What is this? I could do that, but I don't feel like doing that tonight. What's gonna cause this if so? The last thing I replaced before this happened, it was working, but the last thing I replaced was a resistor for SMC something. So maybe that resistor is doing that. Maybe I put the wrong resistor on. You know, I probably did. I think I did that before I had coffee. So we don't need sleep LED right now. Let's forget sleep LED. We could worry about that later. So the last thing I replaced was the other side of the board. Let me open the right one for a 3115. Last thing I replaced was R5488, which is SMC P-Bus V-Sense. Okay. How would you know it's sleeping when it's not working? So let's see. That area that I replaced it, did I mess something up? Is the via screwed up? Let's see. Clock area looks good. I've already replaced the clock chip once to see. The resistor looked really clean. But does it have connection to the via? Yeah, P-Bus V-Sense seems important, but the question is it, let's see, R54, what is it again? R5488. Search. R5488. Maybe the new resistor blew. Gotta open the right schematic. MacBook schematics, R5488. Come on, where are you? There you are. So search R5488, and that is a 27.4K. 27.4 exact. So that's not our issue. The question is I messed with the probe point. Going to the via, does it have continuity to the other side of the board? There's a little coil here, it's not a filter or something. I don't actually have it. But I don't think it's blown either. So I also messed with this area, just tried to clean it up and tin it, but I don't think anything's shorted there. So what I'm gonna do is I'm gonna scrape away just a little bit of the via, and maybe the via is just destroyed going into the board. I'm not sure. Let's see. Yeah, I use NC559. I don't use liquid flux. Yeah, I know that the resistor can handle the same thermal load, but it was I should measure it again. Let me measure that resistor that I changed, just in case, because that's also important. So that was R5419, HS other I out, SMC other high sense, R5419. It's 4.53K. Let's see. So I hate quarter fan spin. It could be anything. For all I know, the CPU is dead on this. So. Oh well. Is that bad or is it my leads? Wait. Wrong setting. Is that resistor blown? Please be blown, that would make my night. I can't tell, my leads are so nasty and dirty. Still, oh well. Try an even higher setting, 20K. 4.54. 4.51, that's close enough. So that's not our issue. Ah, I see a clue. I see something. I see a lot of things, actually. You guys, hang on. Check this out. I think I found it. Again, this is me not looking where I should be. I'm just rushing through things. So, have a look right here. That's Thunderbolt. I actually pulled Thunderbolt, but I don't think this is for Thunderbolt. So, see that resistor right there? See that capacitor? What does that resistor do? So, that's for Thunderbolt, that doesn't matter. That's just for PP Bus G3 hot. For Thunderbolt enable, that doesn't really matter. Yeah, those capacitors do look bad, but that's not going to matter. I'm not going to repeal and replace stuff with Thunderbolt because that has nothing to do with what's going on. So, the question is, do I get 12 volts there? If I do, it's not our issue. But I didn't notice that before, so I'm just going to keep looking, seeing what I'm missing. So, let's see, voltage. And where are we? It's 12.35 volts. Hey, look at that! I'm actually lifting the resistor. I actually lifted the resistor up with my leads. Knock it off the board. We can. We can knock it off the board. Let's watch. Let's knock it. Look how bad this resistor is that we could just knock it right off the board. So where are we here? Look at this. This is going to take no effort. And watch this. That does not belong on our board. I don't really care what that does. But let's get our iron back on. What time is it? 10:26. Okay, I have stuff to do. Is that capacitor? Could that capacitor be holding down one of our 5-volt rails? And no, don't do it. Could that capacitor be holding down one of our 5-volt rails? If it's leaking the ground or shorting the ground. Ship it. Where? Because I don't even have the Thunderbolt chip on here right now. I should probably put that back. I should probably put the Thunderbolt chip back. That's what I'm gonna do. But let's solve this solder situation here. Yeah, you're not gonna rip pads. I gotta put that Thunderbolt IC back on there though. I can't leave that off. I lifted it just so I could see if that was the issue. If we still have a pad there, let's see. Come on. Oh well, no pad. Now let's see if we have another resistor. Let's see. Yeah, close enough. I don't care about checking the values. I'm just gonna put it on there. I want the small nozzle for the smaller nozzle. I'll try that once and rerunning. Yeah, I got lucky. My luck, it's one end of that's going to be connected to the SMC or something, and I'm going to have to pull the SMC and run a jumper under it. Can I fast forward to see if this works? It's not going to work, Chris. It's not going to work. I can tell you that right now. It's not going to work. Brendan, this is a different board. So let's put back Thunderbolt IC. Yeah, the quick is the song to get air from. Get this fume extractor plugged in. I don't want to set off the smoke detector. This isn't gonna work, Chris. I know it's not, but I bridged the connection. A new iron would make life easier, though. No, I don't know what I'm avoiding. What I'm waiting for. I need to get one. Won't work till you pull that SMC. Fine, watch me burn. Watch it not work after I put it back on. Okay, let's do something. Let's see if Chris is right. We are gonna pull that SMC. We will put that. We will pull that SMC, Chris. It bridges connection. I'll use thermal mass on this. Iron is so low, I'm gonna. Try booting it first. There's no need to boot it. Try it a little bit. Make sure, we don't need Thunderbolt right now. I'm not even gonna worry about that. No, I need to put that back. I need to rule out anything that's going to be causing that. So no, I need to put the Thunderbolt IC back on. Just in case that's going to cause some strange issue that's not going to allow it to boot. Wick. I'm gonna use. I'm starting to like wicking with hot air a little better. It's just so much easier with my iron. Quick unit is built very nice. I want to fix this board, so. That wick is very hot. I just moved another capacitor. We're going to lift this SMC. Okay, Chris. Let's see who's right. Let's see who's right. And let's see if I screw this up putting it back on. So, a lot of flux around it. Ton of flux. We're going to preheat, of course. Watching me set up the smoke detector. I fix it tweezers, so things are great for stuff like this. Okay. FM203. That was gonna go. Those are clean balls under there. It's not. And watch, I'm going to screw this up soldering. I already know this board is done. So there's no signs of corrosion under here. I should just refloat it. We have a few missing balls, and I'm not reballing that chip tonight. Let's see. So we'll put it back on. Do I remember the orientation? Oh well, you can't. Yeah, I can't screw this up. Watch. I screw up things that are just. Wait a second. Do I have the orientation right? Did I forget the orientation? It's this way. That doesn't look right. I'm not even thinking I gotta see if we can find a board with that orientation because I don't have burn the SMC. So. See if we can find some pictures online of the SMC. Let's look at it backwards. I don't trust these people online. Can't even tell on these pictures. That's old. Okay, so I traced this. This one looks like I still can't tell. Chris, this is your fault. You made me do this tonight. Yeah, I do that too. Forget which chip is good and which chip is bad. Okay. So I'm going off of these Chinese pictures online. Here's a good one. Oh, that's close enough. Okay. Glad I looked because I had it on backwards. So, let me turn this way. Okay, now watch this. Somehow he screwed this up. And watch this not work at all. It's hard to screw this up. Yeah, it is in the daytime. With these on the SMCs and such, how I screw them up is they'll sit crooked, or they'll sit with like one edge lifted up. As I expected. I'm going to screw this up so it's not sitting flat on the board. Oh no, I can't put this back on tonight. This has to be reballed. So this is why I don't like doing that. Look. So I'll have to reball this and put it back on. Not tonight. See, Chris, this is why we don't do this. Where is it? This would not work. So I'm going to come back in the morning and probably reball this chip and put it back on. But, yeah. That is not going to work. Wait, no, maybe it will. No, I could do this properly in the daytime. It's just nighttime. I'm tired. Let me see. I can't fix this thing up to put it back on. No, this will work. No, it probably won't. There's two pads that aren't tinned. One pad's burned. Yeah, I did pull it early. Let me put some new things up. Yeah, I'm not good with VGA stuff. I'm really not. I'll tin those pads so. No, it's just a dry pad. They're not. It was connected to the board all along. It's Flux. Oh, oh, you know what? Have a look at this, guys. This is why it wasn't turning on. This is why it wasn't turning on. I'm thinking this is my Flux. This stuff is whatever was under it to begin with. See all that? That is... Hang on. Why isn't this working? Okay, see all that, like, garbage? I was thinking that was my Flux. That is, like, garbage. But the question is, the chip is probably dead. And that's a 3115. I don't have that. So, yeah, Chris Long wins. Chris Long wins. This SMC is garbage. So, let's look for a new SMC. Let's send me payment later. Yeah, alright. What about those other couple MacBooks with the dead ISL? So that's easy. So let's see. This is only going to be coming from China. Please tell me there's one from the USA. From Kenmore, Washington. MacBook SMC pre-ball VGA chipset for 820. No way. From Kenmore, Washington. Last one, buy now. So Chris, you were right. Tim Reball is probably fine. Oh well. Yeah, I could reball it. I don't know. Let's try and put it on the board. I'm actually, you know what? I don't feel like truly reballing it tonight. There's plenty of balls on the board. I wonder if I could just tune the pad, like, cheap reball it. No, this is the original off the board. Clean up the chip first. I don't want to reball it tonight. I want to put the stencil and deal with that nonsense tonight. I'm going to clean the chip and I'm going to wipe the chip. That's what all you're getting tonight. Maybe, just maybe, I could use the balls that are on the board. I'm going to tin these up. Because I tried to remove the junk, and that's been through the ultrasonic too, so that's just caked on garbage. What time is it? It's 10:51. I'm tired. I'm gonna go to sleep. So I'm just gonna wait. Scrub it? No. I don't want the chip to move around. So. Just gonna do this. Soft bristle brush. I don't want to. My iron with Flux is gonna do the same thing. I bet I don't even. Yeah, I have a stencil. I want to do it tonight though. So Chris Long wins. He was right. There's corrosion. There was junk under the SMC, and that's why it probably wasn't turning on. Anyway, I ordered a pre-qual chip. I'm just gonna clean this. Now, since we kind of loosened it, now we can scrub. Chris, I've seen you use paste all the time. You do not like the solder balls, so don't lie. So, you know, anyone notices that late at night, I do my best work late at night. Sometimes I don't get it in the morning and I'll get it at night. So I'm really hoping to fix this. I really want to fix this board. I spent 6 hours on this board. You know what? I have an idea. No, I better not. I probably drop it in there. As I say, I could put the chip in the ultrasonic. So now I'm gonna. Yeah, so that was corrosion under the SMC. That's probably what was causing. But what I don't understand is why did it work and then it stopped? I don't know. I guess with current passing through it. Who knows? So let's look at our SMC now, because I know Amtech is not going to make that look like it did. So let's see. It's kind of clean, still a little nasty. I'll clean a little more. It's better. I'm not even going to do this stencil. I'm just going to tin it really good, and then tin the so that I have a new SMC on the way. This would just be a plus for work. I'm just going to tin the SMC really good and attempt to put it back on there. Some looks really funny on this, but I think it'll be okay. It's like the traces were corroded away on the SMC itself. So Chris, did yours power cycle like that? Okay, I think that's clean enough. I don't feel like... Now let's take a vote. Who thinks I can tin the SMC and put it back on there and have it work? Without, you know, there's still balls on the board. I gotta touch them up a little bit. But I think... No, see, this was working and then it just stopped working. And being this hour at night, I'm probably going to screw up the soldering on this, like I said before. Yeah, no, this isn't going to work. Alright, I could try this technique. One technique to reball it. Basically, you wick away the pads on the board. And you wick away, you know what, I don't know if I'm doing that here. I'm just going to touch up my iron on the areas that need touching up. I like to remove the really big balls and tin the SMC really good, and it should make good enough connections. And then I'm done. I'm going to sleep. I'm tired. There's no way this is going to work. No way this is going to work. So what do you think? There's a method where you could create equal halves on the chip and the board. I think that's going to be our best bet, and try and solder it down. So what do you guys think? Whip the pads on the board and then on the SMC and try and create equal halves, or try and drop it on there now, which has uneven balls. I'm thinking I'm going to make equal halves on each side of the board. What do you guys think? Wait for a second. No, we're not going to work and reball them. I don't feel like doing that. That's stupid. A new SMC on the way. I vote for create equal halves. Which is not going to work. We know it's not going to work, but I'm tired. So that means it doesn't have to work. If I'm tired, it doesn't have to work. Touched up with new and put it back on. It's kind of late for that. I hate doing these SMCs. I'm not good at soldering these SMCs. I'm really not. It's one of my weak spots, for sure. You know what? Yeah, there's lead-free balls. I'm going to switch to my small tip, and I'm going to try and make 96 individual balls. That should take a while, but oh well. I want this board to work, and I'm probably not going to have time in the morning to make this board to work, so let's try this. I want to take this tip off. That's being a pain. It's expanded, so it wants to take the whole heating element with it. Come on. There we go. If it works, you're just going to have to take it back off and install it. Maybe. Okay, in 20 minutes, if this thing isn't fixed, I'm going to sleep. So I'm going to put my micro tip on, which is a 0.5 millimeter. It's the smallest tip available for the 88. I'm probably gonna check on it in the morning as well. I'm getting tired. I'm gonna try and do this like this. You know what? I'm not no way gonna be making 96 individual solder blobs tonight on this thing. No attempt to create some solder on. Here and then on the SMC, and I'm going to try and solder it back on, but it's probably going to slide away, and if it slides away, that means it's time to go to sleep. Yeah, this is not going to work. Ah, we are missing we have a burn pad on the SMC, and that is not for me. I think it's a burn pad, is it? Is there a pad there? Let's get light. It's fine. I literally smashed the SMC to the board and cleaned the solder balls off. I don't know what you mean. Just hold it down, is that what you're saying? I'll do that. I'll try at least. There's one pad I'm weary of on here. How is the big adjustable? I did not like that scope at all. The field of view was strange on it, and the eyepieces were kind of uncomfortable. I don't know. I almost bought that scope before I used it. was an AmScope. Okay. There was nothing. Try to get the orientation right. Maybe it's this way. I have to look again because I don't know. So that is this way. So the other way. Put a little flux down. Okay, let's take bets. Who thinks this is going to work, or who thinks it's not going to work? I don't even think I'll be able to get it soldered down properly, but at least a new reed valve is on the way. So. Yeah, this is not going to work. It's just sliding all over the place. Yeah, this is not going to work. Or is it? Did that seriously flow into place? No, this couldn't have. If this flows into place, if that actually... Okay, it moved, so... Let's see if it works. I think it may have flowed into place. I don't know. I don't know. We're having to cool with the alcohol. It'll work. How? I don't even know. The board is still pretty hot. Something tells me to turn it on, but something tells me not to turn it on. Let's spray a little alcohol on it first. I'll just... Okay, it's cool enough. It's not going to get a green light in the charger, and it's not going to work. But let's see. We'll come back in the morning. Yeah, no green light in the charger. Actually, we do have a green light in the charger. No way. No way. Barely. So the SMC has to be doing something. Let's reflow it. It barely has a green light in the charger. Dim green light, wiggle it around, nothing. Okay, so the SMC has to be doing something. Let's reflow it. I'm gonna use the big nozzle. Please work. I at least want to go to bed knowing something worked. Is Chris still here or did Chris leave? Probably left, went to sleep. Come on. Okay, I know it floated into place a little bit in the area. It's partially, it's dancing a little bit. Uh, no, it came off the balls on the board. Yeah. Oh, no way. Oh, come on. I'm done with this nonsense. Yeah, I wasn't actually soldered the whole time. And this in the video I'll be right back. No, it's not. Okay, well, we'll wait for the new SMC to get here. So, that was a big waste of time, so I guess thank you all for watching, and I'll probably do another stream when I get the SMC and see if that does anything. But thank you for watching, and I hope you learn not to work on boards late at night.